Hello and welcome to another video in my lecture series. Today we're looking at complex numbers. And complex numbers have two parts, a real part and an imaginary part. But don't let the imaginary part frighten you because it really is quite real. Complex numbers come about as a result of certain quadratic solutions, and they make perfect sense when you come to think about them. Okay? We can't take the square root of a minus number. However, by making minus 1 the square root of minus 1 and giving it a specific symbol, we can, in fact, deal with that situation. So we use the letter I or J to identify the imaginary part, and we use the letter J in electronics because the letter I is actually used for current most of the time. So to avoid confusion, we use the letter J. On your calculators and in your textbooks, you will probably see the letter I associated with it. Now, if we have the square root of minus 1 and we multiply it by the square root of minus 1, then the square root disappears and we end up with minus 1, which is quite a simple concept. So the minus 1 is actually a real part. Now, the rules for complex numbers are that we keep the imaginary part separate from the real part. So it actually is a number that consists of two parts. Okay, now we can convert between our normal rectangular form where we are accustomed to our x and y, and that is the form in which it's normally taught in the textbook. And we can convert it to a magnitude and an angle by the simple expressions shown there in brown. And these expressions come about as a result of the trigonometry of laying them out onto a plane, whether it is an xy plane or a real imaginary plane. The trigonometry of the system causes this correlation between the magnitude and angle and the x and y components. But we're more interested right now in seeing how we can use them in calculations. So what maths can we do with these complex numbers? Well, we can add them, and it's shown very simply that we add the real parts and the imaginary parts, and we have to take into account the signs. It's an algebraic addition. So if the negative overcomes the positive, then we will have a negative part in either the real part or in the imaginary part, which is the I part. With the subtraction now, we also subtract the real parts and the imaginary parts, as shown there. With the multiplication now, we do what is called cross multiply, which we are very accustomed to doing in maths. So that is, we multiply the first number in the first set of brackets by all two numbers in the second brackets, and then we use the second number in the first brackets and multiply that by all two numbers in the second bracket. So we actually end up with four terms as shown there. Now it is in this context that we find that we have an I multiplied by an I, and therefore that last part becomes a negative real quantity. And then we simply add up all the real parts and imaginary parts to end up with our final answer. It's quite easy to follow once you study it below. And then we come to division. With division now, we have to first make the denominator a real number. It's called realizing the denominator or making it real. In order to do that, we multiply the quantity by the equivalent of 1, so it doesn't actually change the number in any way, but we use the complex conjugate. Two complex numbers are referred to be conjugates of each other if the real and imaginary parts are identical but it's just that the sign changes in the imaginary part, which is quite obvious there. We see we have a plus 4i and a plus minus 4i. So the parts are the same, except that the sign on the I part has changed. Now when we do that and we multiply out the brackets, we see that the imaginary part disappears entirely, and we end up with a real number, a single real number in the denominator, which we can then divide into each part of the numerator. So we divide the real part and the imaginary part by that real number. So once again, if you study this example, it should become very obvious how we divide. Finally, the reciprocal is 1 over a complex number, and we do the same manner. We simply take the conjugate, and because there's nothing on top except 1, the conjugate becomes the numerator, and the denominator becomes a real number, just like we had before. Now finally, if you put your complex number into polar form using your calculator, all calculators have a polar to rectangular conversion key or keys that will easily make the transformation between x and y and r and theta, the angle, as was outlined in the brown in the first slide. But it's interesting to know that if your numbers are in polar form, you can simply multiply the magnitudes and add the angles to do a multiplication. And if you want to do a division, you simply divide the magnitudes and subtract the angles as shown there. And that's it for complex numbers. Complex numbers in less than 7 minutes. Have a great experience, and we'll see you in the next video.